I don't know about you, but I'm having a blast. Let's keep factoring. Numerator, 2x plus 5. Denominator, all right, let's just simplify things a little bit here. There is a denominator that has a negative in the front, so we really have negative, and then x squared plus 4x minus 5. And then that factor is even worse. We're going to have a negative 1 right there. And that's going to give us, let's see, x plus 5 and x minus 1. And because of that, something's going to cancel. I see it. You see it. We both see it. There it is. 2 over negative, and then x minus 1. Okay, wonder what that negative does. Flips it over. There, I said it. I whispered it so you wouldn't hear it. But we have an x-intercept, maybe. A y-intercept, definitely. Holes, no, not holes, plural, holes, singular. Hole because we canceled a factor out. Vertical asymptote, horizontal asymptote. Let's keep driving. Take your fast car and keep on driving. X-intercept is where you set the numerator equal to 0. So 0 equals 2. No, it doesn't. So there is no x-intercept. Y-intercept is y equals 2 over negative 0 minus 1. It's going to give me 2 over 1, so y equals 2. Ah, there's a dot right there. Okay, we canceled out a factor of x plus 5. So that means that x equals negative 5 is going to be the x-coordinate of the whole. Well, let's keep going with that idea. If I plug a negative 5 into the reduced form, which will go right here, we'll have 2 over negative, and then negative 5 minus 1. So then 2 over, let's see, negative 6, that's going to be positive 6. That's 1/3. So the y-coordinate is 1/3. So negative 5, 1, 2, 3, 4, 5, and then 1/3, so just a wee bit up from that. That was not well done, but it's there. Vertical asymptote is where your denominator equals 0, so negative, and then x minus 1 equals 0. We can divide by that negative 1 in the front. It gives us x minus 1 equals 0, so x equals 1. Let's draw that. And for the next part, we're going to go all the way back to the very beginning of the problem. We could do it here. I just choose not to. Let's go back to the beginning. What's the degree of the numerator? 1. What's the degree of the denominator? 2. We want them to be the same, which means we're going to need another degree in the numerator. So it goes back to school and gets its master's degree. That was funny. All right, we have 0x squared in the numerator. So our horizontal asymptote, you can graph it and see that. And again, we've been through this. Because there's no x-intercept, that means we don't touch the x-axis. We're going to have y equals 0 over negative 1. I'm looking at the leading coefficients here. And that's just 0. Which means, again, we will not touch or cross the y-axis. We'll cross it in terms of like jumping from one section of the graph to the other, but we'll never actually like cross that line. Don't cross that line. Okay. Let's graph what we have, and then we'll talk about discontinuities. I made it sound like the most amazing thing ever. We're going to talk about discontinuities. It's going to be great. It's pretty cool. Okay, we're not going to get too technical about where the other coordinates go either. So again, if you're like, oh, well, that coordinate's off, and it should be at such and such a place. Yeah, I know. General shape is what we're going for. General shape and the other coordinates, the x-intercept, y-intercept, and then the whole in the appropriate place. Okay, disco time. No, I'm kidding, the 70s are over. Let's draw a line right here so it separates those. The discos, there are 2 of them, occur here and here. If you drew this from left to right, you would have to pick up your pen here at negative 5. No surprises, so that is a removable disco at x equals negative 5. And then jump back down to there, and that's going to be a non-removable disco at x equals 1, and that is the vertical asymptote.